Underlying mathematics for Q-Qnorm plot. Step 1. Calculate mean, standard deviation, and cumulative probabilities in sample data. A running example. Suppose we would like to use Q-Qnorm plot to check whether sample data with 5 observations is normally distributed or not. The 5 observations are ordered from the smallest to the largest. Let's calculate mean, standard deviation, and cumulative probability. Given only 5 observations, it's not difficult to calculate the mean is 0 and the standard deviation is 5. The second column is the order of the observations from 1 to 5. Let's calculate cumulative probabilities. Cumulative probabilities can be calculated by using different formulas. The current formula is variable position used by Stater. If you pay attention to the formula, only order and the total number matter. Actual values does not affect cumulative probabilities. Let's go through each observation one by one. For the first observation, the cumulative probability is 1 divided by 5 plus 1, roughly equal to 0.1667. The cumulative probability is illustrated by the figure at the bottom. The shaded area is the cumulative probability. Let's look at the second observation. The cumulative probability is 2 divided by 5 plus 1, roughly equal to 0.333. The cumulative probability is illustrated by the second figure at the bottom. The shaded area is the cumulative probability. For the third observation, the cumulative probability is 3 divided by 5 plus 1 equal to 0.5. The cumulative probability is illustrated by the third figure at the bottom. The shaded area is the cumulative probability. We continue to calculate the cumulative probability for the last 2 observations. The fourth one, the fifth one. Step 2. Identify corresponding quantiles in the theoretical normal distribution. The left side is the sample data and the cumulative probabilities that we just calculated. The right side is the theoretical normal distribution with mean equal to 0 and the standard deviation equal to 5. You can now pause the video and think about why the theoretical normal distribution has a mean 0 and a standard deviation 5. Let's continue. I hope that you get the point. It is because the theoretical normal distribution has the same mean and the standard deviation as the sample data. The shaded area is the cumulative probability for the first observation in the theoretical normal distribution. X1 is the corresponding quantile in the theoretical normal distribution. Identify the second corresponding quantile in the theoretical normal distribution. The shaded area is the cumulative probability for the second observation in the theoretical normal distribution. X2 is the corresponding quantile in the theoretical normal distribution. Identify the third corresponding quantile in the theoretical normal distribution. The shaded area is the cumulative probability for the third observation in the theoretical normal distribution. X3 is the corresponding quantile in the theoretical normal distribution. Identify the fourth corresponding quantile in the theoretical normal distribution. The shaded area is the cumulative probability for the fourth observation in the theoretical normal distribution. X4 is the corresponding quantile in the theoretical normal distribution. Identify the fifth corresponding quantile in the theoretical normal distribution. The shaded area is the cumulative probability for the fifth observation in the theoretical normal distribution. X5 is the corresponding quantile in the theoretical normal distribution. Step 3. Compare quantiles between sample and the theoretical normal distribution. The left side is the sample data with the cumulative probabilities. The sample data can also be viewed as sample quantiles corresponding to the cumulative probability. Right side, x1, x2, x3, x4, x5 are the quantiles in the theoretical normal distribution. Therefore, x1, x2, x3, x4, x5 are also theoretical quantile. We can compare sample quantile with theoretical quantile. If sample quantile equal to theoretical quantile, sample data is perfectly normally distributed. If sample quantile roughly equal to theoretical quantiles, then the sample data is roughly normally distributed. If sample quantiles are far away from the theoretical quantile, then the sample data is not normally distributed. For these concrete examples, let's look at the x1, x2, x3, x4, x5. x1 equal to minus 4.8371, sample quantile, smaller than theoretical quantile. x2 minus 2.1536, sample quantile, larger than theoretical quantile. x3, 0, sample quantile equal to theoretical quantile. x4, 2.1536, sample quantile smaller than theoretical quantile. x5 equal to 4.8371, sample quantile larger than theoretical quantile. If sample data has only a few observations, we may compare each observation with the corresponding theoretical quantile. With increased observations, it is not practical to compare each observation with the corresponding quantile. Instead, we plot sample quantile and theoretical quantiles. That's step 4. Plot quantiles of sample and theoretical normal distribution. The observed quantiles and theoretical quantiles form coordinates. Theoretical quantile are x-axis and the sample quantile are y-axis. In this case, we have 5 points, 5 coordinates. That we make a scatter plot based on these 5 points. If you look at the scatter plot, it's still difficult to quickly evaluate whether sample data are equal, larger, or smaller than the corresponding theoretical quantiles. Here's the magic. We add a reference line. If points are below the reference line, such as the point 1 and point 4, the points are smaller than corresponding theoretical quantiles. If points are above the reference line, such as the point 2 and point 5, the points are larger than corresponding theoretical quantiles. If points are on the reference line, such as the point 3, the point is equal to corresponding theoretical quantile. In general, if points in Q-Qnorm plots are all on reference line, then the sample data is perfectly normally distributed. If points in Q-Q plots roughly fall along reference line, then sample data is assumed to be normally distributed. If points in Q-Qnorm plot are far away from reference line, then sample data is not normally distributed. This is the end of this video. See you next one.